Now question number 5, it is an interesting puzzle sort of a question. And the question is, each integer is coded with exactly one of the 3 possible colors, black, red or white, satisfying the following 2 rules. Now the first rule is negative of a black number must be colored white. So if we have a black number, then its negative must be a white number. And the second rule is sum of 2 white numbers, they must be colored black. And these numbers, they may not be necessarily distinct. Now the first question is, we have to show that negative of white number must be colored black and sum of 2 black numbers must be colored white. So from these 2 given rules, we have to prove that negative of a white number must be colored black. So for this first part, what we'll do is, we'll suppose n is a white number. Now, if we'll add n with n, then we can write n plus n, and it will be simply 2n. Now, the second rule says sum of 2 white numbers must be colored black. So, this 2n is black. Now, in the question it says negative of a black number must be white. So, we'll take negative of this number. So, we can say minus 2n. So, minus 2n, it will be a white number. Now, minus 2n is white and n is white. So, if we'll add minus 2n plus n, we'll get what? We'll get minus n, and the rule number 2 says sum of 2 white numbers must be colored black. So, that means this minus n is a black number. So, that's our first part. Negative of a white number is a black number. Now, for the second part, which says sum of 2 black numbers must be colored white. So what we'll do is, here we'll choose 2 black numbers. Say n and m, they are black numbers. So if n and m, they are black numbers, we know that negative of a black number is a white number. So minus n and minus m, they are white numbers. Now we'll add them, we'll get minus n minus m. So sum of 2 white numbers is a black number. So minus n minus m is a black number. Now in the question again it says negative of black number must be a white number. So if minus n minus m is a black number, then we can say n plus m is a white number. So if n and m are black numbers, then n plus m is a white number, and that's our second part, which is sum of 2 black numbers must be colored white. Now we'll come to the second part, which says determine all possible colorings of the integers that satisfy these rules. So one obvious condition is we can paint all the integers as red. So if all the integers are red, then they satisfy all these given conditions. Now, if suppose all the integers are not red, then some of them they'll be black, some of them they'll be white, and then others will be all red. So what we'll do is we'll assume that let n be the smallest positive integer which is not red. Say which is black. So we'll consider the case when we have taken this n to be the smallest positive number which is black. Now our claim is once we decide color for this number n, then the color of all other integers, it is already pre-decided. So we have to prove this claim. So in order to prove this claim, we'll prove another result, and which is sum of a black number and a white number must be a red number. So we have to prove that sum of a black number and a white number, it must be a red number. Now we'll prove this result using contradiction. So we'll consider this first case, that suppose the sum of a black number and a white number is a black number. So we'll say we have two numbers, say n is a black number m is a white number. Now our assumption is black plus white is black. So if n is black and m is white, then n plus m, it must be a black number. Now in part 1, we have already proved that negative of a white number must be black. So if m is white, then minus m is black. Now we'll add them, we'll get n plus m minus n. So it'll be simply n, and the sum of two black numbers, it must be a white number. So from here we can say this n, it must be a white number, which contradicts our initial condition that n is a black number. So from contradiction, we can say that black plus white, it cannot be a black number. In the same way, we can prove that black plus white, it won't be a white number as well. So we can say that sum of a black number and a white number, it must be painted red. Now we'll come back to our claim, which is if the color of n is decided, then the color of all of the integers, it is pre-decided. Now what we'll say is, suppose this n is 1. That is, suppose 1 is the smallest integer which is painted black. So if 1 is black, then 1 plus 1 is 2. So sum of 2 black is white. So if 1 is black, then 2 is white. Now if we'll add 1 and 2, 1 plus 2 is 3. So sum of black plus white will be red. Now 2 plus 2, sum of two whites is black. So we'll get 4 as black. And then 4 plus 1, black plus black, it will be white. So 5 is white. And then again 1 plus 5 will be 6. And they'll again be red because it is sum of a black number and a white number. So from here we can see that all the numbers which are of the form 3k plus 1, they'll be colored black. All the numbers of the form 3k plus 2, they'll be colored white. And all the numbers which are multiple of 3, they'll be colored red. Now what if we take n as 2? That is, now 2 is the smallest number which is black. Now we know that 2 plus 2 will be 4. So if 2 is black, then 4 is white. Now if 2 is black and 4 is white, then in that case 6 will be red. Now what about the color of 3? Now if 3 is black, then black plus black will be white. So in that case 6 has to be white. And if 3 is white, then 6 has to be black. But 6 is red. So it simply means this 3, it has to be simply red. In the same way, we can say this 5, it should also be colored red. So here we can say that numbers which are of the form 3k plus 1 into 2, they'll be colored black. Numbers of the form 3k plus 2 into 2, they'll be colored white. And the numbers of the form 3k into 2, they'll be colored red. And all other numbers, they must be painted red as well. So from here we can say that if n is the smallest positive integer which is not red and which is say black, so if n is black, then all the numbers which are of the form 3k plus 1 into n, they'll be black numbers. All the numbers of the form 3k plus 2n, they'll be white. And all the numbers of the form 3kn, they'll be red. And all the numbers which are not a multiple of n, they'll be painted red. And on the other hand, if we choose this number n to be white, then in that case, the remaining numbers will be determined by the same rule. So here, black and white, they'll be simply switched. So this is how we can determine all possible colorings of the integers which satisfy these rules.